Hello everyone and sorry for the delay. Welcome to We Meet at Digital Days. My name is Lisa Richter and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is how energy harvesting can make your application autonomous. Basics, examples and applications. Our speaker is Laurent Völkel. He will hold the presentation and answer your question. Before we start, I would like to point out one thing. You will be muted during the presentation. This means that you cannot ask questions via microphone during the presentation. Nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. You will find the chat function in the control panel. This presentation will be about 30 minutes long. The chat questions will be answered in a Q&A session following the webinar. There are 5 to 10 minutes in addition scheduled for this. If we are unable to answer all of your questions within this time, we will answer them via email afterwards. If you still have any other questions left, just mail us at exhibition@we-online.com. We will try to answer all of your questions promptly. At the end of the webinar, you'll be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to improve our event. You will receive the link of the presentation in the next few days. The recording will be available at our website shortly. So now I will hand over to our speaker, Laurent Völkel, and I wish you an exciting presentation.
Hello, everybody. I hope you can hear me now. And my name is Laurent Völkel. I'm field application engineer at Würth Elektronik, working over 20 years with Würth. And today I will present to you something about energy harvesting. When you talk about energy harvesting and you try to do a kind of autonomous application. Okay, let's start here with this one. Yeah, the first thing what you think about energy harvesting, it's always you think the energy is for free, and yeah, in fact, you try to collect some non-electrical energies around you, and try to catch them somehow, and you might want to make without any maintenance and totally autonomously. So that's actually the motivation when you're talking about any device which you want to make energy harvest. First of all, you have to find which kind of energy form are around you. So second, then you need to transform them with a transducer or a harvester somehow. Additional, you want to store the energy for the time when you're not using and just recall it when you need that to operate. In the mechanical age, we did use that kind of buoy on the water when the ship approaching the port and it was foggy. Then the waves which is generated from the ship start to make that this bell ringing, and people was on the ship and here, okay, we are too close to the ground. We should take a little bit more space and make the bell not so loud. Today, by the digital age, we have this kind of buoy as well, but this time they are operating completely autonomously, collecting solar light. They are operating by solar cell and as well movement from the wave. And now with this GPS local position from Earth, they can put in the same water street more like one ship. To develop such kind of device, you need in every stack, in each module, you need very high efficiency and low power consumption. And this is the key in energy harvesting development. You are scratching on the edge of the technology sometimes. You want to achieve 99% efficiency. Perpetuum mobile is still not possible. First step, when you start developing, you need not just the maximum current consumption of your device. You should know the peak consumption, and you should know what is the consumption during the sleep time. Sometimes there are some possibility to put the processor in deep sleep mode, and during the deep sleep mode, the current consumption can go down to nanoamps. So this is the most important thing when you start development, to know your peak, the time, how much is this peak, and the rest time when the electronic is not need to operate, how much energy is taking. And then you can start to make a calculation. And the next one, you can try to find out which non-electrical source are available around your device. It could be light, like ambient light or outdoor light, solar. It could be a temperature difference. To use a thermoelectric generator, you can use a temperature difference. If you have more like 5 degrees Celsius temperature difference, you can use a TEG. If you have vibration, you can use this motion and harvest it. If you have chemical substances like a very high pH value, you can make a battery from your wastewater, like example. The most important thing is, before you start your development, to use a logger and to see how long this energy is available. The next step is the most difficult one, to choose the right harvester. I know this is not so easy. I did make this energy harvesting development. I think I researched more like 6 years already. And this is the most difficult thing, because we electronic engineers, it's very difficult for us to develop a mechanical system. And you need a mechatroniker. This mechatronic is a new, yes, a new engineering. And you need something, or you need a good partner company who can do for you this harvester, because there are not too many standard harvester which you can take from shelf and from stock, and that's the most difficult issue. The next step is to make a DC-DC voltage converter. Of course, this is also, you need a good engineering, because you want to aim 95% plus efficiency. Then you have to consider where to store this energy. You can store in capacity bank, you can use super cap, you can use this kind of ultra caps. It's a mixture between lithium polymer and supercap, or you can use rechargeable lithium ion or lithium polymer batteries. Today, you can harvest even RF. If you are living very close to a mobile phone base station and you build a nice Yagi antenna, you can put a LED on end, and you can make bright this LED to shiny. But that's not the good. I would not recommend to do that, because a country like in Germany, even that is illegal to do. Um, you can harvest RF, but it's the most inefficient harvesting. If there's no other possibility, I know one company they made some Wi-Fi harvester devices. The problem is, where you place this Wi-Fi harvester, and they are a little bit more efficient and make some energy harvesting in this area, you will be not able to use your Wi-Fi device. So I would say this is not the best solution, and maybe you can try to do with some different source like vibration. By vibration, you can harvest already 1 milliwatt per centimeter square. By thermal, a standard TEG 10 milliwatt per centimeter square is quite standard. I saw one company, they make some prototype where okay, it was more like 60 Kelvin temperature difference. They can reach 1 watt per centimeter square, which is quite enormously. Can you just imagine, if you have 1 watt per centimeter square, to put that TEGs on the cooling water for atomic plant, and you don't need this big heater, big cooler for cool down the water for the turbines. Photovoltaic is the most efficient today. You can reach 100 milliwatt per centimeter square very easy with a standard one. Interesting, why is that the harvester today becomes more capable, they are more efficient, and the processor, the electronic, is going down the consumption. And I don't talk about mobile phones. I don't think I will live enough that I will be able to have a mobile phone with energy harvesting. Well, a hearing aid, a pacemaker, some RFID tags you can do today by energy harvesting, definitively. We did make with collaboration with linear technology, which is belong today to analog device. We did make this kind of demo um, kits where you can make your first steps for developing energy harvesting, because this demo kit contain everything what you need for making an autonomous electronic in a low power, of course. You have here a power board where you can harvest thermoelectric, you can harvest solar cells, you can put the solar cell in parallel and serial, you can connect here inductive or piezo harvester, and the DC-DC converter on this energy board are that smart that they make the energy management by themselves. They can harvest multiple sources at the same time. They have an output for a capacity bank or to a supercap. You can put on one output to lithium polymer to be recharged. You can use primary battery, secondary battery, and the smart board. This is containing from a former company, Dust Network, which belongs to Analog Device as well. It's an ARM Cortex M3 core with a built-in already RF module. On the processor stack is already RF module on it. You have an output to antenna, and that's it. It's using 2.4 gigahertz proprietary protocol, and it's a mesh network. You don't have to carry on the network. It can be in the same time repeater, actor, sensor, gateway, whatever. And we put here in display to be able to read what is the energy demand, what are the commands, and you can see here on this connectors, you get with this demo kit also a shield board, and on the shield board you just push on this connector and place it, and you can put your own sensor or own electronic. It's like kind of small breadboard where you can put different application, and you have access to this module directly. You don't need to buy a second unit and make another PCB for you. Same time on the back side, I don't have a picture from the back side, should be maybe next time put a big picture from the reverse as well. There are two column counter, and the column counter need more energy like the energy harvester can supply. You have a USB port here, and if you download the quick eval from Analog Device website, you can even measure how much energy this board is taking. The column counter need more energy. That's the reason why you need this USB port to supply them. On the power board, you can see there are different DC-DC converter, and depends now on your source, which kind of energy source you will use. If you use only just a solar cell and piezo, or you use piezo solar and you want to use also lithium rechargeable, you can decide with the switch and with jumper which IC you will use for your application. By the smart board, like I told you, it's an ARM Cortex M3 core. It's an E-ink display. The E-ink display, we decide for that because the E-ink needs the pixel only energy when you have to change his state. So in the rest time, it doesn't need energy to uh, power on something. The only one issue which I realize it when I'm use that device for application, which I try at my home outdoor. If you leave the e-ink display in directly solar light, you should cover it maybe because it get polarized from the sun. So this is the e-ink for indoor application. If you look on the LTC 3330, this is a solar harvester with a piezo together. On the piezo, we did use that from MIDE. If you go to our website, you can see this piezo harvester manufacturer as well. You can see here the output voltage is constant. The energy harvesting until is no harvested energy. It's take energy from the battery. We have this primary cell. As soon the harvester start to operate and deliver energy, it disconnect completely the battery. It means you can extend the lifetime of this kind of battery application up to 15 years. That was a calculation made from Analog Device, but this is quite very real if you have a low power demand. Of course, you can even put here optional super cap because have a balancer also for super cap as well. The first harvester, but you ever use it in your life and maybe you don't realize it, it was a dynamo on your bicycle. When you put this not so efficient mechanical dynamo on a bicycle, even in the past you did feel it that you need to push more your bike, and that was efficiency less than 10%, but it was already energy harvesting, motion energy harvesting. You don't realize it. Maybe today, by the new bikes, they have this axial generator, which is not so. Um, they are more powerful, and they are not giving such feedback for you that you realize it, that you make your LED lights on. Different company like Ferro Solution and Perpetuum, they are using in UK for harvesting the wheels from the train. They harvesting the vibration on the train wheels, and they also in a mesh network, and give information to the gateway in case of one of the wheel get a crack, the fingerprint of the vibration changing, and then the gateway can communicate via mobile network or satellite network and give information to the train management of you have to take care of one wheel on the wagon 5 have a crack, and you should slow down or stop the train, whatever depends on the system. But it's a system which is working quite very reliable, and yeah, if you want to have anything in this direction, ask these guys for support. If you want to develop something by piezo harvester, I can recommend this kind of PI ceramic harvester. They have some different standard sizes already. I glue it here to carbon piece, and I can use that using just a little vibration on the desk, and already the box start to operate, and it's very simple application for piezo harvesting. By using a TEG, you have the problem that TEG start at very, very low voltage, 0.3 volt. And 0.3 volts or 30 millivolt is not enough for this NP junction to be conductive. And because of that, you need a booster. For this reason, of course, Würth Elektronik developed the right component here, which is a small transformer, which making a boosting 1 to 100, and then the IC start to operate with a good voltage and deliver the output voltage. But do you realize that I say a DC TEG converter operate a transformer? How can a DC voltage operate a transformer? Normally you need a AC current, you need a flux, you need a change in current to generate this magnetic flux. Well, the smart thing is really this IC3107, because you can see on the schematic you have a node here, the switching node, which going directly to the transformer primary, and as soon the voltage start to rise, during the rising you have always a flux change, and you will generate electricity, and the first thing what this IC will start to switch on and switch off this leg, this pin. Switching on off this leg on the input, you will always have here a flux generated. You will always have an AC, and you will generate 1 to 100 voltage up. Of course, this is not the most efficient, but this is the only one way how to make input of the this IC to operate from 30 millivolt up to 500 millivolt, and with this you can operate and then store some energy somehow, and then put the output to the operating. This is the component from us that's called also EHPI inductor. How we made them? Well, it's not a big philosophy. You can see here the mechanical cut on both. You have a bobbin core. You have here 1 to 50 the wires. You can see the primary 1 to 50, the secondary 1 to 100 here. You can see on the left picture, this is 1 to 100. Here, the 1 to 100 ratio, we use the wire thickness, which is thinner like human hair. The thinnest wire which a winding machine can operate, we use this one. And the secondary winding is, the thickness is not that thick because we want to power a lot of amp through. We choose this wire to have less losses as possible because of the DC resistance, to keep them very low. This is the component EHPI, which you can try to use in different turns ratio. If you have even a special demand, you can ask us and we can see if this is possible to be produced in mass. Components, yeah, this is a standard component you can get from stock. If you need free samples, just ask our sales guys on the field. Where is energy harvesting used? Well, we know some customer from us, they're using that for tracking the containers on the ship, because the big ships are having kind of vibration during they operate. They have a ground vibration. The German railways use energy harvesting over 20 years already. There are some building automation possible. Companies already have standard switches, remote monitoring for pipelines. Companies are developing already, and some of those, I have NDA, I cannot say the name, they're used for tire pressure monitoring system, already energy harvesting on it. So energy harvesting get more and more popular today. Companies like ABB using for temperature sensors, also a completely autonomously device using RF mesh network, standard product. They use the sun himself to harvest this energy, and you can see the heat sink here. It's operating perfectly. It's industrial tested. It's beautiful device. You don't need maintenance. Can you imagine if you put that in some places where you have no access, how bad it is to go and change the battery every 6 months? Company like Fraunhofer, they develop also a very nice solar cell with system on chip. You have below the solar cell also the processor, which has power management. They use capacity inside, and they use also a three axial motion sensor, and you can put that in this vacuum area in the window, and you can sense if the windows is closed or open, or if it's a crack, something like that. So we make a question to our customer, and we ask them what was the lowest harvested energy and what was the highest one, and we find out that the minimum lowest power was 50 microwatt harvested, up to 200 milliwatt was the average, and the biggest and maximum harvested device, it was a 5 watt using solar cells. It was for a meteorological station somewhere in the mountains, and they use this for the GSM and for the GPS position. But there are many different applications already on the market, or where energy harvesting already is the used source. The interesting was also this water purification plant measuring the pH value, and the water himself was the battery, in fact. Very nice experiment what I found on CES for 2 years ago. It was presented for the company who nobody will imagine that they develop electronics or they make energy harvesting devices. It was the company L'Oreal. Actually, everybody knows from this um, kind of stuff, chemical stuff, cosmetic stuff, and so on. And they develop a very nice sensor which you can glue it directly on your fingernail, and it's measuring during the day using the UV light, and measuring the amount of UV light which is getting to your skin. And on the evening, you can take your mobile phone, and by NFC, you can read the amount of UV light, and you can see the harvester. It's a UV LED. They use a UV LED like a solar harvester, and they store this energy in a small capacitor and put all this data in a small processor. And on the evening, by using this antenna for NFC, you can read your mobile phone how much energy, how much UV light you get, and according to that, you can decide which sunblocker you have to use next day. A very interesting harvesting device, again found on a Brazilian guy. He used a device which during your sleep and you're snoring, the snoring noise is charging your mobile phone. It's very funny, and they use it also. You can use it outdoor also if you make enough noise, or you breathing fast enough. You can also move these small elements, and you can recharge your phone. Yeah, I was impressed by this application. Even he get the Red Dot Award for that device. And by today pandemic, you can use that also like a mask. In the same time, you just have to put additional small HEPA filter. I don't see him any mass production, but if he would be clever, he would put now a HEPA filter inside, and this is a nice application for energy harvesting. So if you want to do anything by energy harvesting, you just have to ask us for these different demo kits. We have two of those. One is developed with Silicon Labs. It is without RF. This is the to-go kit. You can have also TEG, and you can have also solar cell and the piezo input. The solar cell TEG is already on the board. It's no RF module on it. If you use the RF module, it's an energy kit which containing also a dongle. Now I will go to the questionnaire and I will try to open now this questionnaire area where I can find the questions.
So thank you, Laurent. This was a great presentation. So just have a look at the questions. Maybe we will start with the first one.
I'm trying to make that bigger to see what is in the question because I cannot read it else. Okay, I found a button. Somebody asked, which storage device do you recommend for outdoor usage? Light is not acceptable as is not recommended for temperature down to minus 20 degree up to 40 degrees. So which storage device between minus 20 to plus 40 degree, 40, 60 degrees Celsius? Thank you for this question. Well, it depends how much energy you want to store. Ceramic capacity bank could be one of these definitive good application. I know also super caps are minus 40 plus 85 degree operating. Lithium cell would be not the best option. Maybe that would be a solution with capacity bank, many different capacities in row, or a super cap. Another question. What generator is recommended when we have high ambient temperature and indoor? It's jumping now because question is coming in and I need to expand again, else I will jump away. So what generator is recommended when we have high ambient temperature and indoor installation? It's very dark. Okay, if you have a high ambient temperature, automatically I'm thinking about TEG. The thing is, you have to find a way to cool somehow. You need a heat sink, so you have to realize to make this temperature difference. So some heat pipes, if you have a possibility to put some heat pipe to outdoor, or if you have a big heat sink, whatever, high temperature is always good for TEG, thermoelectric generators. Somebody asked again, can you please tell a few words about the low power RF part on the kit? Okay, thank you for this question as well. The kit doesn't have a low power harvester. The kit have a low power communication module. It is the operation by 2.4 gigahertz mesh network, and it's a proprietary protocol. It was developed from dust network, which have been purchased from linear technology, and linear technology have been purchased from analog device, so they belong to analog device. This is the most efficient communication in energy harvesting I ever seen. During the device doesn't have to communicate, everybody is shut down and no communication at all. And by the first communication after making the enjoying the network, it will be communicated when the next time it will be any communication. So the processor is very smart programmed. This firmware is very interesting. So they know when they wake up, they listen, and if there's no communication, they go back to deep sleep mode. And in deep sleep mode, the current consumption is 150 nanoamp. During the receiving is something like 10 milliamp, and during the maximum power transmitting is 50 milliamp transmission. Normally, when I make my own setup, I have very simple device which is looking if my garage door is open or closed. I'm using a small mechanical generator with a electrical motor, and during the transmission to my home, which is maybe 15 meters away, it's using 25 milliamp during transmission, and on the receiving 10 milliamp. It's quite okay. It's very stable and very good, very reliable for jamming as well. Another question. How about the stability of multilayer ceramic capacity in vibrating environments? How can we assess the risk of crack and resulting a short? Oh yeah, thank you for this question. Excellent question. Um, for the ceramic capacitor in the vibration environment, you have to think about this piezo effect also, can happen on the capacity as well. And you have to decide of the size of the capacity in that way that this, if you have a high um, vibration area, um, maybe it could damage. In this case, I will go from ceramic capacity to polymer capacitors. And the polymer capacitor are not so sensitive for that. Thank you for this question. It's a very good one, but honestly, I would choose instead of ceramic one, a polymer one. Another question. There is a technology that use the natural resource directly, not like storing the energy in the solar application. That use the natural resource directly. Well, it depends of the current consumption of your load. If your load is less current consumption, like the source are generating directly, and you don't need to stop your device, and you have always this harvested energy available, then you don't need to put any storing. So I know one application where really you have just a small capacitor on input of the DC-DC converter just for the ramp up uh, first inrush start of the device, but this is only just by the first operating milliseconds. This is the only one storage. The rest is always flow through. It's operating without any storage application. This is possible, of course.
So thank you, Laurent, for this nice presentation. I think if there are any questions left, we will answer them via email afterwards. So thank you all very much for your attention. I hope you enjoyed our presentation. And yes, see you in the next presentation and enjoy the digital days. Goodbye.